Hello, 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 and welcome back to another Binary Ninja stream, Friday, October 17th, 2025. I hope today's gonna be a chill stream. I previously promised maybe doing an interview today or working on some plugins, but I've got some things that I just want to reverse on today, doing some bug hunting if you saw my tweet. Um, in the last 2 weeks, since our last feature stream, the 5.2 feature stream, we had Hexacon, and there was an incredible turnout. Thank you for everybody who came and said hello. We had a lot of really good questions, actually. I feel that only a couple people who came up didn't know what Binary Ninja was. One of those people was actually the waiter, who also works in security, just a different type of security. But they were all very interested, and everyone was super nice. You said hello. Thank you for saying hello. I know a couple people watching the stream today. We're talking about our last couple streams. So, and everybody who was at Objective by the Sea in Ibiza, I hope you guys had a great time this week as well. I heard it went great. The talks at both Hexacon and Objective by the Sea, I heard, were fantastic. So if you can try to catch those online, I don't know if OBTS stream, or no, I know that it did stream them actually. So go try to check those out and check Hexacon's out too. And yeah, last bit of news is we announced our second keynote speaker for Reverse, Lori Wired. She makes some fantastic videos here on YouTube, which I really recommend going and checking out as well. I recently went through a whole bunch of them and they're really good. So I hope you guys enjoy that, and I hope you guys enjoy her as our keynote speaker. Now, I got the question about what's today's stream going to be about. And as I said, we're going to be doing some bug hunting. And we're also going to be, nowadays, we're going to be at the top of each stream doing State of the Ninja. And we always like to wrap up with something community based as well. So today's State of the Ninja is going to be a tip of the week. So I'll pop open Binary Ninja here. And what I want to show you guys how to do is how to use the API to model a couple of instructions to automatically find them. We can open up any of these binaries here. We'll go through and look for BusyBox. This is an example I don't really use in class, but I've used in some of my talks. I've got a bookmark on a couple functions here. There's this call to system, for example. That's not a particularly interesting one. This one is, though, with the addition in it. So let's try to find all calls to system that have an addition in their first argument, or maybe just all calls that have an addition in their first argument. Either one can work. All right. Now to do this, of course, we're going to be using the API, and we need to get all the instructions first. We could, in particular, because this is a call, we could actually get the function called get function by name, functions by name, because you can have multiple functions named the same thing. In this case, system, we've only got one, so let's grab the first one. I show people that a lot. Technically, it's incorrect. You really ought to handle all the functions named a given thing to be complete and correct. But often it's good enough just to grab the first one. That's why we provide the DV get like function at. You can see there's the singular version there and there's the plural version there. Usually you're only going to have one function at an address, but you can have multiple. You'll see this pattern throughout our API. I recommend when you're writing your scripts, do the easy version and then you can complicate it later. In most cases, this isn't too sophisticated or too cumbersome. At worst, you're turning singletons into lists or lists into dictionaries, stuff like that, to accommodate the multiple things named the same or multiple things under the same identifier. But even so, there's a little bit of accommodating for it, especially if you've architected your overall code in some more strict way. All right, so we can get functions by name, and this is system. So let's name it system. And then you can do system.callers. On this, you have a handful of things. You have your call sites, for example. that's all the calls being made inside of system, and specifically the locations of that call. So the stub system calls this version of system here, the God entry. Um, the callers are all the people who call you. You also have callees. This is all the things you call. It's interesting here that we have call sites, a call site, but not a callee, because that's not a real function that we're making. So we've got our callers. We've got our. You can also get your caller site. This is the one I like the most. It's a generator, so we need to wrap it in a list. Underscore gives me the last value from the Python REPL. So we can now see that we have our three call sites. If we go ahead and say call sites equals underscore, now that's bound to a variable. And I can cycle through this for site and call sites. Print out the site first, and then I can get some tab completion on it. You can see that you can actually grab the high-level IL for that instruction if you need to. And now we can find all the calls to system with a +1 if we want. But that's not really the point of what I'm trying to show you here. Usually, if you can narrow down your search space, you want to as much as you can. So, cool. So that you're not scanning, 100 megabytes of code. That would take a while. But in this case, BusyBox, this is actually a decent sized binary. Let's see how long it takes to cycle through all the instructions. For inst in bv.highlevelIL instructions, we could cycle through all the functions. We needed those function objects, and then we could cycle through the basic blocks in those functions if we wanted to do things very verbosely. But we can also just ask for all the instructions if we want, and we can print those out. Printing them is probably going to take longer than actually cycling through them, but it didn't take long at all. So in this binary, it's fine to go ahead and do this. Otherwise, you might want to find like some sort of anchor point that can be a string or a constant, and then you can find the functions those anchor points are used inside, and then you can scan all the instructions within just that function instead of having to find instructions in the entire binary. But on small binaries, you don't have to worry about that. Again, there's the easy way to do things, and then you can make it more complicated, make it more robust if you need to. All right, so in this case, I want to find all call instructions. So if I go through this and I say if inst is instant or if is instance inst, and now this is going to be a call instruction, high-level IL call instruction. And we have another magic variable for that. So if we do the current IL instruction, we can grab that current IL instruction, and then we can say, and it shows us right there, it's a variable initializer. So we actually need to get into the right-hand side here. If we ask for the source of that, we can see that's a call. So if I iterate through everything, if is instance, and I ask if it's a call, we're going to miss this particular instruction. Let's print all the call instructions, and now let's also just ask, yep. We got the source, and we can get the address. There you go. So we can grab the address of that. What is that in hat? Exactly what I expected to be. Perfect. So now if ox pat equals inst.address, now we can print the instruction. Otherwise, and we can break. Let me make my code a little bit bigger here so you all can see it and keep on that call to system. Okay, so if we don't break out of this loop, I want to say, just print not found. All right, and hopefully it should print not found. Running, there we go, not found. Now that could be troubling. If we take a look at this one here, we can just sanity check ourselves. This one is a top level instruction, so we should find this one, and it shouldn't print not found. There we go, exactly. The problem we're encountering here is that these instructions are trees, and you have to descend down the subtrees, down the leaves of that tree to find all the actual instructions being run. You could drop down to medium level IL if you want. There's a lot less code folding in medium level IL, which can make your scripts somewhat easier to write at times, but it's also less optimized. There's more temporary variables in medium level IL. So you will be processing, like right here, there you will be processing more nodes in your analysis, but your nodes will be simpler. So it's your trade-off. I like to try writing everything for high level IL, and then if I discover I'm shooting myself in the foot, I can drop down to medium. But I know plenty of other people just stick with Medium. Medium's what we do our data flow analysis on. So if you're doing anything similar to that type of analysis, where you really need to explicitly track values through things, often people have better luck with that in medium level IL. But I certainly have plenty of SSA tracing variable scripts that are written to work on high level IL as well. So we're still trying to find this instruction, but it's in one of the leaves of the instruction. And let's actually visualize that. What do I mean when I say that this is a tree? Well, if you install Tonto here, and I have both Tonto and DevTools installed, you're going to need these instruction slices for what I'm about to show you in the DevTools. So install both of those. I wrote both of these, by the way, so even though this is third party, you don't got to worry about it too much. We can go over to the Tonto view. And I'm creating a split pane here. Tonto works best in two panes like this right now. Don't try to make Tonto just a single pane, especially for what we're doing here. If you click Create New Slice, you can check out the instruction slice, instruction graph right there. And then if I click on that instruction, Tonto is going to be extremely context aware. So if you select the whole line or you select that equals sign, you'll see that this is a high-level IL variable initializer. It has a .dest, which contains a variable object. It has a .source, which has that call, and that call has a destination as well, which is going to be a pointer, which has a .constant, which has the integer address of the system function. And then it also has params. And in this case, system only has one parameter. Parameter 0 is an addition with a left-hand side and a right-hand side. If I just select the call to system here, if I just select system, it's going to show me that that particular part of the instruction is that constant pointer. If I select the parentheses, though, I can get a little bit more, and that's going to show me the entire call now. I think that this is a lot of fun to play with, and you can hit the addition to just see the add of the subtree. If you're looking at other instructions like this one, you can see the assignment with the call inside it, with the call inside it, with the constant pointer and addition inside that. With just the rather variable inside that. The constant pointer is the address of that function it's calling. But this is great for when you're working with the API. We can see now that this call to system, again, is on the right-hand side. So you could, if you want, go back here and try to pull out both instructions or instruction.source, or we can just simply recurse into the subtrees. There is an existing plugin that does this. Ryan, in fact, has told me to nuke it from the plugin manager now that we have this one, but it's BNIL Graph right here. The only feature that BNIL Graph has that I need to re-implement is this match generator. It will. I also think that it doesn't currently work on. If we drop down to medium level IL, I think I have a bug. Yeah, you can notice it's not updating on the right anymore. So I need to fix a bug in medium, and we're getting some errors in our console. I need to fix a bug, and I need to add the ability to automate the generation of these matchers. Ryan's will show you all the ILs at once and just dump it to you. It also has levels of indirection in here. So you don't get just the low level IL dot des dot left dot source, you have some intermediary nodes in there, whereas this one it is the instruction dot source dot param 0 dot write. It is telling you explicitly all the different things you need to put into your match statement or into your case effectively. But yeah, as soon as I get the generator, the match statement generator in here, we'll probably remove Ryan's. Again, he's asked me to. But haven't gotten around to that. All right. So yes, we can recurse down these subtrees. And it's the most powerful API in Binary Ninja. It's also one of the most flexible and potentially one of the most confusing APIs in Binary Ninja. I love it though. It is the traverse. So every instruction has, or an IL instruction, has this traverse method. And in the Binary Ninja console, if you didn't know, you can throw a question mark after everything to see the docstring. And this is the exact same docs you get from the online or local the HTML documentation. Just not rendered as nicely. And there's a whole bunch of stuff here. You can see that it takes a callable, which takes a instruction. It can take anything else, and it can return anything else. As I said, and several examples here. It's an extremely flexible API. Let's go through how to use it. So, first, you're going to be cycling through the instructions you care about. That can be every instruction in the binary view. That can be every instruction in the function that has the anchor point that you care about. It can be every call instruction of a certain function you care about. If you have a bunch of calls to malloc, maybe you want to find that, or sorry, I meant memcopy. Malloc would work too. But if you have every call to memcopy or a similar function, you could grab that third parameter, and maybe there's an addition or a multiplication or a subtraction in there, and you want to just find those because that alone would be interesting in my book. But um, that would be a way just to shortcut it based on calls. In this case, again, let's just cycle through all the instructions. I'm showing you guys how to make just any generic instruction matcher, basically. So, cycle through every single instruction here. Let's let's leave that actually for now. And I'll leave the rest of our code in there as well. So, we can just do inst.traverse. And remember, this needs a callable function. I usually use the function called traverse, and I need to define that. It takes an instruction. It can return anything it wants. I'm going to leave out the type annotations for now. Let's just say pass. So for instruction in all of our instructions, we're going to call traverse on each of those instructions and give it our function that's doing what we want it to do. The other thing to remember about this is that this is a generator. So if I do this, and I very often do this, nothing will happen, and you'll be very confused. So you need to yield your generators. You either need to just say for blank in generator or for result. You can wrap it in a list if you really want to. However you want to do it. Let's do for result in the traverser, and let's just print the result. All right. We also need to return something, so let's go ahead now and return every instruction. This is going to show us exactly how the traverser traverses through every instruction in the program and like the order in which it's recursing down the sub-instructions. Let's give that a look. And there are a lot of sub-expressions in all the instructions in this binary. And there are a lot of instructions. But if we take a look at this assignment here, we can see we've got, oh, this one's interesting. This one it's the assignment itself. And then it's also on the right-hand side, it is the address of operator. And then the source of that address of operator is the variable itself. We find this return. We can see that it is a return. It's a tail call, actually. It has the Oh, that's funny. It's navigating me up there. Didn't mean to do that. It has the destination of the call or the call itself. Then it has the parameters inside of that call. And then that's probably a different instruction, I'd have to guess. We could print the addresses of all these and take a look more. But if you guys can very easily re-implement this and dig through this yourself. And now we get like a more interesting one. We've got the return instruction, and then what's first? What instruction is this? I guess this is an add with a left hand side. Sorry, the left hand side. Yeah, the left hand side is going to be all of this. And then the right hand side, you can see we come back to the right hand side all the way down here. And then we go into recurse into the left hand side, which is again another add. And the left hand side of that is a variable. The right hand side of that addition is this zero extend with a left shift in it, then just the zero extend, then just the dereference, then just the add, then the register, then the constant, and then we pop back up the stack to get to the right hand side of the right shift over here, and then again that +8 on the add at the top. So yes, the instructions are trees, the trees are deep, and we need to recurse through them, but we have this very convenient and very easy to use API that does the recursion for you. You can think of Traverse itself as non-recursive, which makes writing recursion a lot easier if you could pretend it's not. All right, so what are we looking for? Again, we're looking for calls. So if I select this here, I can use, well, I'm looking for calls with adds in them, just because I'm trying to find something interesting. Actually, let's switch to a different binary. I have a much better example for you guys. Let me take this off screen. This is going to be one of the binaries, if it'll let me take it off screen. One of the binaries I use in our classes for Binary Ninja, our trainings. This is a sort of toy example of a binary that decrypts itself, a unpacker of sorts. You can see right here in a loop, we have an XOR instruction on some buffer in memory. Binja got the length of that wrong. Looks like this is all random junk data. One of my favorite key combos in Binja is 1 to make everything 1 byte elements, and then asterisk to make an array of those elements. We could maybe have included these. I can hit 1 and asterisk again to do that if I want to, but I don't think that that padding was actually supposed to be part of the string. Maybe it was, maybe it wasn't. Actually, one of those zeros was probably intended to be a part of that string. We do like our null terminated strings there. All right, that looks better to me. And then if we go back up to main, just hitting the back button on my mouse here, we can see, okay, we have some random buffer getting the encrypted flag variable. We're sign extending the iteration variable because it's only 32 bits. We're extending it to a 64-bit number, it looks like, and respecting the sign, and then we're XORing each byte of that encrypted flag with 10. So if I XORed all of this here, transform, I've never actually done this in linear view, I don't believe. There we go, that looks right. Not sure what's happening in the other view. Maybe it was applying NDNS or something like that. They're still live, right? Google is buffering on my end. There we go, cool. So maybe something weird was going on there. But the point of this is that we can now find, instead of finding all calls, we can find all XOR instructions. And then we could add a little filter on that to find all XOR instructions that happened in a loop. And then we can find all unpackers without having to do some sort of byte pattern. So in here, Instead of looking for call instructions, let's go open Tonto again. Create that instruction slice. The name is optional. That'll come out of the next release. That little menu bar there. It gives it a default name for you. And you can rename them up in the top right if it's important to you. So if I go ahead and select this instruction, I can do, first of all, the entire instruction, and this is a beefy instruction, or I can just click that XOR, and it's still big, but we've got a high-level IL XOR, and I want to say if, well, we can say, I believe, if inst is that, but it's better to say is instance that. Or no, you can't say is in that case. Not sure. We could try it, but this is the more reliable way. So if it's an XOR, let's simply return that instruction. And now this is how we find all XORs. Instead of just returning the instruction, we're returning all the instructions of a given type. And now you can imagine just applying consecutive filters to this to find the specific instruction we care about. And in this case, we find, looks like I found 2 right off the bat there. And it's done. Let's also print the inst.address in hex probably, and the result. There we go. So now, oh, funny, yeah, it did decrypt the string for us. So we can go in here and let's try this again. It says that it has only 2 bytes selected at the moment. Now we've got, it's still only saying we've got 2 bytes selected in the bottom right. So I guess we can't do this from, if I do it like this, and if I do it like that, it'll let me do it. Interesting. Well, usually you're going to be transforming things in hex view. If you hit H, you can go down here, select the blob you want to transform, and then stream XOR. Let's re-encrypt it there. Back to that fused string. That looks a little bit better. We're getting 3 XORs. I'm not sure where that third one is. We don't need Tonto. We will use Tonto again, but we don't need it right now. We've got that one. We've got that one there, which I believe re-encrypts the string. Oh, and then we have this right here, which is just our stack cookie check. Cool. So we can ignore that one. It would be nice if we could find just all the XORs in a loop. And now I could give you guys that, but we have achieved the goal I wanted to achieve, which is simply being able to write these instruction finders. I will take this one step further. If you guys rebel enough in the chat, I'll show you how to find out if it's in a loop or not. But let's see, let's match this instruction instead. This is new Python syntax. If you've never seen this before, welcome to the jungle. This is a lot of fun. We can make a case statement with the actual class that we're trying to match, the class of the instruction we're trying to match here. So if I pop open Tonto again, and we're in the instruction graph. Oh, I think I need to reswitch to it. There we go. All right. So if we're in this XOR, you can see so this right here, this is your template. Copy this from the screen, and you're going to make all your instruction matchers based off of this, just filling out the different cases. Using Tonto, having the instruction you care about up, it is just going to be copy and paste from here. So high-level IL XOR with a dot right of some sort of constant. And now this is how you match every XOR with the right-hand side of a constant in the binary. We could, let's return those. We could also say with left-hand sides of constants. And we're going to be using this a lot today because we're going to be looking for some CVEs that have to do with subtractions in unsigned comparisons that could underflow or overflow. This will be extremely useful later today. Just building out all your different cases effectively. Or literally. And there we go. Now we're finding the two XORs with simply a constant in the right-hand side, which did manage to filter out the cookie check. But maybe that's not a good thing. Maybe that is a good thing. Again, write your scripts the easy way, get some results. If you find out that you're getting some false negatives or some false positives, then you can go in and refine your script. But with Binary Ninja's API, you can get things off to a pretty good start pretty quickly. So that's today's tip of the day. How to use Binary Ninja's API and Tonto to do some instruction matching and automatically identify all sorts of things in binaries. You could on open, and there is a after analysis completion callback. You can call a function, run every matcher you've ever built on every binary you ever open, and maybe you add tags to those locations instead of printing them to the console, and those can be the places you begin looking at different binaries. Cool. Which transitions wonderfully into CVE 2023 22098. Let's open that up. Let's not save any of this stuff. Don't save. All right. So I already have it open over here. This is it, CVE 2023 22098. This was a vulnerability in VirtualBox that allowed escalation, a privilege escalation, I believe, ultimately. There were 3 bugs. It was 98, 99, and 100 that were all related. If you look at them on Oracle's 2023 security alerts, you can see all 3 of them right here. I guess the only 3 bugs found in VirtualBox that year, or in their virtualization in 2023. We can go one step further. You can go ahead and download version 7.0.10 is affected, 12 is not affected. So we'll take a look at bindiff and try to see the diff later after we identify where it is, just to verify that it was patched and also just to play with bindiff. If we can, it would be nice to get some unstripped symbols for VirtualBox and use warp to apply those symbols to the older version, then use bindiff and possibly migrate those annotations forward, but not sure if we'll get to that today. We can take a look at this bug on Google's security research repo. This was found by Andy here. I learned about it at TyphoonCon back in May, I want to say, from his keynote, in which he was saying, Andy is famous for finding a bunch of the PlayStation jailbreaks. He's spent a lot of time looking at PlayStation stuff, and he often, according to the keynote he gave at TyphoonCon, gets asked, where do I start? Where do I begin? What are things I can do? And one of the things he recommended in that talk was look for all unsigned comparisons with subtractions in them, or all comparisons with subtractions in them, or additions in them, or multiplications in them. Those could be interesting starting points. You have to start somewhere. There are lots of different points of interest you can find and you can use in binaries. I often recommend maybe the biggest function, the most called functions, the function with the most calls in them are sometimes good starting points. Those can indicate where a lot of the main logic in a program is located, or where the real main is. A function that calls a whole bunch of other functions is a big dispatch. It is the core logic of the binary, is my reasoning usually. But maybe you're looking for other types of features. Again, if you're doing more just vuln hunting, maybe you want to do something more like what Andy's suggesting. Look for all the subtractions and unsigned comparisons. maybe it's one of a dozen other things. If you have your own like pet points of interest that you like to look for, feel free to throw them in chat or in the comments. I'd love to learn. I've been asking people a lot, like what their favorite primitives are, and I've gotten some really interesting answers, which I'll hold on to for now, because I might talk about it at some other point. Um, yeah, in fact, I wanted to say up top, at Hexacon, I was practicing and asking a bunch of people some interesting questions, which were leading to some fun discussions. And I hope that you guys come by November 17th, I believe it is. Let me double check my calendar here. November 14th. We're going to be interviewing Tim Blazeko. He's going to be answering some of those fun, hard questions I was asking people over drinks at Hexagon. All right. So here's the bug. It was in the VirtIO network adapter. Yada yada yada. The diff itself, proof of concept. The following function handles the stuff. This was on my notes. I say there was a weird constant that is sometimes checked whether the value is greater than the max rather than the value being less than the max. I believe there was a slightly different description of it over here. Execute all the vulnerability. Yeah, these are sort of just high level descriptions, not giving us too much more actionable details in here. Out of bound write, denial of service, denial of service. This, which fetches the VLAN ID value from the guest. Here we go. Is that it there? If we're checking if CB remaining is greater than that, whereas we should be checking that the remaining bytes we have or whatever it is are less than what we're looking at. Oh, yes. It's saying that right there. The check is wrong. It should be the opposite. Cool. So in this case, one of the thing, or yeah, sorry, it was a little further down. It wasn't that size of. It was this constant there. Um, let's try to find this in the binary, and then we can talk about it a little bit more. So I believe I have those all ready to go. We've got the old version of VirtualBox and the patched version of VirtualBox. Now, the first problem we're going to have is that there's a lot of files in here. Where is this code? How do we even begin to find where this CVE is from this report? It doesn't mention a specific DLL in here. I believe that this was a cross-platform bug as well, so it could have been in a shared object or a dilib instead of a DLL. I just happen to be looking at the Windows version. So we need something to key off of. And thankfully, I see a handful of strings. So let's just grep for some strings. Pretty easy. If we go in here, we can go into the old version of VirtualBox. And I also have the source if we want to take a look at the diff later as well. So many things in here. Let's just go ahead, grep-r. By the way, I am going into this blind. I want you to know. I did do this step just to make sure I could find the function, but I didn't go further than that. Um, and what I noticed earlier is that these strings don't show up, which is wonderful. I wouldn't want the strings to show up anyways. These are log prints, though, so these might get compiled out. Let's look for this one instead. One of these should work. And then this will tell us just which file to look at. That didn't work. If I take out that. Let's see, that's in the assert message return. There's also this. This is a different log function, but this looks like a legit error. So that could hopefully stay compiled in. If not, oh, there we go. Cool. So just again, using anchor points, something that should be in all versions of this program to find what we're looking for. Let's see. Start message return. Right, we've already got the binary. So virtualbox.dd.dll is the one we care about. Virtualbox.dd.dll, dd.dll right there. And we can go over to Binary Ninja now, and let's drag that in. There we go. Let that analyze for a minute. You can see it running in the bottom there. Oh, another one of my notes is in cases like these, it would actually be interesting to just try to find all constants used in a binary and like maybe ask an LLM or maybe do some clustering to find the weird constants and then just look at how those constants are being used throughout the program. Just a thought. All right, so that binary is done analyzing now. We can search for the same string we were searching for before. In here, not that. The string was coming from this log rel function. And there we go. So we can find the string, and then we can get the cross-reference to the function it's used in, and it looks like it's only used in one function. Thank goodness, makes our lives easy. And this function is a little chunky, but not too bad. And that string was being used specifically. Updating my cross-references would be nice. There we go. I had to double-click the string. All right, and it's being used right here. So that's in var 70. It gets passed down to this block here, which seems to be a block a bunch of things are returning to, which makes sense because it's the default case in this switch. But we're looking just at the top of that switch to find there's definitely other things happening in this function that are not happening in the source code here. In fact, like everything on the left probably, anything that this doesn't go back to. There are 3 arrows coming in, which should be our 3 cases, and then there should only be one above that. Interestingly, it was definitely not compiled as a switch statement. We can see there are these cascading if chains here. Can we? I don't know that we can convert this, coerce this to a switch statement. We can show it as inverted if we want. But since it's not, I believe, if else if chains, it's not giving us the switch recovery option there. But it would be cool if it could. So we've got one case over here. And I just want to find the parent of basically all these. We've got one there. So let's actually be good about this, be good reverse engineers. We're identifying blocks that we care about, so let's highlight them. Our tools are interactive. The fact that they're interactive is significant. One of the tools has interactive in the name. And this is why. All right. Now, what Binary Ninja has that other tool doesn't is the ability to look at this code in graph view as the compilation. And then just visually, I can say, okay, all of this is probably one case, all of this is probably another case, and all of that is probably the third case, which doesn't quite line up with what we're seeing here, but something got inlined. It's close enough. I have then no idea what's going on in any of this other code, but we need to identify the code that is common to all three of these blocks because that'll hopefully be this stuff up here. And we're looking for that comparison going into that assert message return. And that particular function looks like it's called twice. So if we just walk up, I believe we're going to get here eventually. And then we'll probably get up here. And yes, in the back of my head, I'm thinking that I should definitely write a simplifier in Tonto that would help you with this. Just identify common parent nodes. There are fancy program analysis ways we could solve this problem, but we could probably do something automatic for that as well. I'm seeing 4 arguments there. This looks like this function takes 1, 2, 3-ish. I'm a little confused by this extra set of parentheses. So let's say 1, 2, 3, 4, up to 5. 1, 2, and 3 to 5. Which makes sense for some sort of logging function, potentially. Whatever. And that second argument looks like it's going to be a string. I don't think that this is our logger. This looks like it gets called a lot. But what's that arg4? Oh, arg4 is coming from the parent. I don't believe. Yeah, I don't think that's our logger. So let's name that not our logger. And we can do the trick I was showing you guys earlier. We have current IL function as well. And we can get call site just to see calls. What is it? Current IL function dot call. Is this not on? Yeah, it's probably on the just normal function. Current function dot callers, call sites, all those things. And now we can say for site in the call site s.hlil would be nice. And ideally we'd filter out all of these, but I'm just trying to find, okay, maybe, well, we've got the RT log logger, which is not one that's in the source, which is fine. Maybe these log funcs are being expanded to that. Maybe even our message, assert message returns are. We could look at the source. Are we going to? Maybe eventually. But let's also print the um, s dot address in hex. All right. So we have our hex view here. Not our logger, that one. This one looks interesting to me. RT log logger X. Got some interesting strings in there. Unrecognized control packet. Um, Not quite what we were looking for, and also not in the area we were expecting to see it. We really were expecting to see it over here. But maybe things got reordered. Maybe it ended up way over here for some reason. What we can also do is we do know that we're looking in this function for comparisons against a constant, specifically greater than comparisons. So I am curious about what's going on over here. There's clearly some sort of very large structure being accessed. Um, or an array, and it's just unrolling the individual byte operations out of it for some reason. Confusing, strange, bizarre, or potentially entirely mundane. What controls whether or not we go over there? If RCX1 is 0, RCX is coming from the out parameter of not the logger. So what are we passing as an out parameter? I think that's probably this call here with the size of, yep, okay, cool. So let's rename that whatever that is. And now we no longer, N, there we go. We no longer care about that. But we do know we have that 2 there. So that's probably, well, size of, I don't believe size of that variable is anything we care about in this function because we just want that other constant. But that call to that function should be somewhat immediately below that. And we don't see this, so we're assuming that this got compiled out, that got compiled out. Or no, this couldn't have gotten compiled out. It got expanded. A bunch of things got inline. So we are still looking at, but are we looking at the failure case? Maybe we should look at the source code for this function just to get a better sense of what that's doing, what it should have been doing. I would need to go into the source for VirtualBox for that. N-source. Yeah, I should have expected that. LLMs have ruined me. Part of me is tempted just to throw it in ChatGPT and tell it to find me where it is defined. I guess we could .h's. Could just open it in a real code editor. It would be neat if I could just grok the definition somewhere though. Guess what do we think that this returns? Void? Slim chance, but maybe. In the meantime, let me get VS Code open to that. That folder. And now we're searching for this assert message return in this folder. Find in folder. Here we go. It's a pound define. Makes perfect sense. If else. Okay, so I think we're going to our positive case. Otherwise, we return. Or we do some other things. So let's go down. Or the green branch is probably all the error handling. I think the green branch is all the error handling. That's what my intuition is telling me. And that would make sense with a bunch of weird test bit stuff and maybe some global structure it's putting error information into. And then the actual code we care about is down here. And we're still, what's that check going to be? Is it something from the code we were just looking at? It asserts an if in there, the expert. Okay. So that's why the lines of code look super weird, because they're pre-processed, all this nonsense. And also the assert message return. Yeah. So I don't believe that. I believe that is still this here. And then we're looking for this nonsense. Oh. Hmm. I had the thought for a second there that it was this check, but this is an equals equals check, not a less than check or a greater than check. But where does it put that first part of that first parameter? It is, yeah. Forgive me for not being able to read this perfectly. A lot of equals equals. Hmm, I don't think it's down that far, but it could be, and that is maybe it. But you feel like we're missing this over here. I'm very tempted to say that this assignment to one is it, but I don't think it is. It shouldn't be, at least. Oh, the expression could also be getting duplicated. We scroll enough to the left. We've got that RDI underscore one is less than two. That structure member access is less than two, equal to three. Um, where else is it? Down here. There's string at that location. That's not a navigatable address. Wonderful. That is a bizarre constant, though. And then we have that over there. I was hoping this would be a little easier, that the source code would be a little bit more close to the binary, but it looks like there's just a bunch of weird preprocessor stuff in addition to um, some compiler optimizations, reorganizing things a bit. But I do think that this potential structure member here being compared to less than two, which I'm seeing in a couple places in this function, is potentially what we care about. Yeah, I believe I see it in three cases, but it's a little bit hard. I would actually really like to build a just like duplicate expression finder for in Binary Ninja, highlight, find all instances of this, but we know how to do it now. Let's go back up to our template right here. This is the instruction we care about. Let's go ahead and open up Tonto. Create new slice, instruction graph. We've got that same thing all the way at the top. Is this, well, just because I wasn't expecting to see that multiple times. Oh, and again, that two. Yeah, if we look here, I do think I might still be looking at the wrong, um, constant. So let's find out what this constant is supposed to be. We've got That's defined as 4096. So where is there? I do believe I saw 1000 in here. And a constant finder would be nice as well. Can we just do that and find actually? If we look for a constant in high level IL, it's almost certainly not going to be in decimal. Um, Current function. You can search for things in the current function, but again, almost certainly not in decimal there. If we grab the hex representation of that 1000, yeah. Just sanity checking myself. Oops. Find OX 1000. All right. So that should be our faulty check. Which is interesting that it's not happening in all cases. But we see that called the function we care about just above that comparison, which is what we were expecting from this. They should have been in the same basic block unless all the reordering stuff's going on. Uh, yeah, I guess that kind of makes sense. But cool. So we use the find window instead of the API to find the 1000. We could still look for all of these, but it didn't say that that was vulnerable. It's also, again, it's interesting how in Binary Ninja, the parts that we inline versus the parts we don't inline, we've got that. I don't even see where that subtraction is happening, but we could try to, maybe we can turn that into a structure. Let's say that it's at least, well, let's just give it no size. And then we could see all the places this is being used. It is being used a lot of places. But anyways, we've definitely found the comparison. This is coming from the second argument there. It's just sanity check. Yeah, okay. So this is definitely our buggy comparison here. Now, what's unfortunate about this is it is just a random constant, and I wouldn't want to match on all unsigned comparisons of just 1000, where we're checking if a variable is greater than that. But we could see where all instances in the program where we use 1000 and see if it's ever being used inconsistently compared to other uses of it. But it does look like that is the one place we are using this constant, which makes this hard to model semantically. How do we represent this for more than just this individual specific case? Um, well, I guess my first question is how many places in this DLL do we do that unsigned comparison in general? So if we go back to this matcher, and now we do the thing with Tonto. Where's my 1000? There it is. If we do this, um, we can, by the way, go to the if statement. The if statement has a dot condition. If I just select this, it's still going to show you that dot condition, which is probably a bug I should fix. But we can grab this high level IL, compare unsigned greater than or equal to, where it has a right hand side of a high level IL constant, just like we already have. I could say unsigned less than or equal to as well, or the greater than with the constant on the wrong side. Let's just start with this. See how many results we get. And we got a lot of results. Tremendous number of results. So this is, oh, and we see, including 1000 actually, more times. Let me kill this. This is giving us way too many results. I refuse to believe that these are all vulnerable. We could say that this has to be a variable, and that variable has to come from yada yada yada. But again, I believe that we might be trying to model something a little bit too specific, something without a lot of this. Again, I was hoping this would be a more special constant. I was also hoping that it would just sort of fall into a more universal pattern. But this is not right here like a bug class that we can model generically. I'll think about this more that now that we've identified it. We can throw a bookmark here, or just a tag in general. Add tag. We know we have a bug here, and we know that it is CVE 2023. This one here. So we throw that there, and we come back to it later potentially. Is there anything else I wanted to do on this particular binary? Oh, yes. I do want to find this in the new version and compare the difference. We could definitely find end days on diffs where we notice that the sign of a comparison got reversed. That would be pretty funny to me. So let's go ahead and open the newer version of this binary in my downloads here. We've got this, and it is VirtualBox DD.dll. Is it going to be a similar address? This does look like a similar function, and we see the same exact comparison. So maybe this wasn't what we were looking at. So now let's use bindiff to figure out what's actually different between these two versions and what might be vulnerable. We can do that, I believe, under analysis. Okay, it's not under analysis. I have a bunch of plugins installed. Um, Export header file, bin export. There we go. So this should be the old version. May take a while for large binaries. Binary Ninja will appear unresponsive. Cool, didn't take too long. And then export again. And this will be new. Okay, let it do its thing. Sweet. And now I don't actually have the bindiff viewer plugin installed. You can generate the diffs in Binary Ninja, but to actually view them, you can load them into, I believe, bindiff itself, or use this plugin to look at them in Minja. And I want to look at them in Minja. So we've got the old version open. We got bin export was right there. Sometimes it takes Qt a minute to update the plugin options. All right, or you can just restart. Let's go ahead and save this. Save it in here. And then restart Mojo. So we have the old version. Plugins. BinDiff Viewer. I believe that this is going to be the primary. Let's see how this works. Got the old one. Where did the new one go? bboxdt.dll. Oh, there it is. Okay. Let's move that up. Okay, cool. So we got the new and the old. Those are what we want to compare. It's not letting me open the file. Interesting. Maybe I need to open the other binary. I don't think you do, but perhaps. No, it's not letting me open any of those either. Well, this is what, hopefully, documentation is for. So it shows opening the diff files here. Oh, and do I still need to generate the diff between the two files? We've got the bin export. Our documentation also, hopefully, yeah, bin diff bin export. Uh, is that still true? I don't believe that this is still experimental. Yes, that is not. We need to update those docs. So to trigger the plugin and create a .bin export file for the current binary, go to the bin export menu or use the bin export action in the command palette. New file extension will automatically be appended if successful. Yep, that's all good. After creating the before and after, you'll want to install bindiff and run the CLI to create the actual diff file. Do I have bindiff installed by chance? There was a slim chance I had installed it way back when. Just download the pre-built installation thing. We can download the damage file. Giving me this. Go ahead and install that. Agree to give away my firstborn son. Google. There we go. All right. bindiff is installed. Now we can open BinDiff. Here we go. File diff settings. Cool. New workspace. Just double check. Where we were in the docs. This is all the VirtualBox stuff. We don't care about that right now. Don't need any of that. We can put the source code away for now. And then, all right, we were over here. All right, so yes, you'll want to use BinDiff, run the CLI to create a .bindiff database. I think I'll do it that way because I don't want to make a project or a workspace or whatever this is. Do we have BinDiff now? Oh, we do. Cool. So we can do, there we go. We can do exactly as it says, BinDiff. Let's grab the old one and the new one. Is that the right order? Writable 2. Sure. I'm going to guess that it is the right order. Some statistics there. We actually have the diff file now. And hopefully you can't hear my cat who really wants to play. She's got a toy in her mouth. She likes to carry it around and scream. After creating the database, yeah, we just want to, all right. I think plugins, BinDiff viewer, match file, up a directory. Yes. And we're currently, I don't know for the primary or the secondary. I'm going to guess the first one is the primary. Okay. And now we're getting function matches. And it looks like addresses haven't moved around too much. We're currently in 18, 12, oh, yeah, 18 BE. There's a lot of functions in here. Okay. 18, 1, 2. Oh no, I'm wrong. I'm off by a factor of 10. 1801. Lots of scrolling. 1801 to BE B E10. There we go. All right. So this is the function we care about. They have a whole. Oh, did I just sort the list? No. Okay. Oh, maybe. No. Okay. Cool. BE10. That's correct. Very similar confidence. What happens when I double click this? Brings me to the function and nothing else. I could port the symbols over if I had symbols. Do I have symbols? I renamed something. I renamed that, I believe. What happens if I do that? Port? But I'm not in the one I want to port it to. So let's open the new one. The front one from .12. And we'll do, first of all, should always check the instructions just to make sure I'm not doing anything too silly. Oh, and we've got, for everyone who's been doubting me that I just get broken Finder windows, here's my broken Finder window. Thank you, Rusty, for telling me to kill all Finder to fix this, but I'm not going to do that while streaming. So we'll just put it off to the side for now. My dedicated monitor for broken Finder windows in Tahoe. We love it. Um, all right, so we don't need any of this. We don't need any of this. Where are my docs? The resulting file can either be opened in the BinDiff Java GUI or in BinJet itself, and it supports porting symbols. Okay, well, it's told us we've found the same one, but the instructions end there. So let's go back to that offset, which is weirdly and conveniently exactly the same. Am I sure I was looking at the right version? If we go to strings, it should have the version we were looking at 7.0.10. 7.0.10. Well, that could do it. Okay, that could certainly do it. Maybe let's not look at the same binary twice. I'm glad we had difficulty finding the CVE in the patched version. We've got the .12. Let's just clear all these. Go ahead and open. Yeah, looks like I just only opened it in the new version. My bad. Let's open up the old one. Let's actually be kinder to ourselves. Remember, interactability, note taking, BinDiff doesn't close when you close Binja. Spooky stream. We've got Undead Finder windows and Undead Binja windows. I don't know if we'll be streaming on Halloween. If we are, I'm not sure what we'll be doing yet, but it is 2 weeks from today, and we do stream every other week. So we'll see what happens. All right. I'm going to pull out this file here, copy, pasta. We'll name that old. Maybe we should be better about this. 7.0.10. And then we'll name this one ddd.dll. Paste that in here. Rename it again. Dash 7.0.12. We can delete all these because apparently I generated those on two versions of the same binary. And now we can open these up. Oh, I don't have Binja open. You'll notice that I've got, and not on there. I've got some things registered to open with Binja by default. I thought I saw one. Like I have .exe, .mako, and .elf all set up to open with Binary Ninja. I should really add .dll to that list so I can just double click those. All right. So what was that magic string we had earlier? Starting again. If you've just joined the stream, welcome. You've actually missed quite a lot. We did a lot of good tips up at the top of the stream on how to model instructions, and now we're just doing that again manually. Okay, cool. So we're looking for this is the string. Which was the string? This was the string we were able to identify. Let's hide the feature map. Search for this string. It's used in one place, in one function. We've got that open now. We can do the same over here. Find its cross references. All right. So now we have the old one open and the new one open. And if we look now up here, looks different than it does over here. So this is now definitely different binaries. 100%. And we know the name of this function. We stole it from over here. I believe it to be, it might be part of the assert message return nonsense, but I believe it to be that actual interesting function. Whatever. Let's just give it the name of that other function. If I'm wrong, I'm wrong. We can come back to that later. But now, we should still be able to find that comparison with 1000. I believe it was down this branch somewhere. We can search for the constant in high-level IL and navigate to it that way, which shows us it is there. Let's highlight this block so we stop losing it. I'm going to do white. Cool. And then our actual three cases down here, 1, 2, and default, which is just this ASM bit set, an ASM bit clear with a structure member, and a log print. As the default case, the unrecognized VLAN subcommand. Unrecognized multi-queue, unrecognized other thing. But if we've got that comparison here, we have the vert IO call right above it, this here, then the buggy comparison, and then is it the two cases in the default case? Set, clear, unrecognized VLAN subcommand packet. That's what it is. Okay. So this is actually our function, like 1, 2, 3 here. Let me tag this with, will it? Yeah, it would be really nice if I could recover this as a switch. Because it is a switch internally. With the 0, 1, I guess default case here. But this does seem structured such that it might be difficult, if not, well, difficult to restructure as a switch. Not sure. Anyways, um, we've got our set, we've got our clear, we've got our thing, we have the buggy comparison. Now, we can see build to create worker threads. It's in here. But it did get flipped around. Yeah, we've got the unsigned less than or equal to and the unsigned greater than or equal to. Okay, cool. So we finally found our bug. I still don't think that we can semantically model this because, again, this seems pretty benign outside of context. There's nothing in just this instruction. And there's not even really anything in these couple of instructions that indicate to me that this is a bug. I think you kind of have to be reading source here, understand the intention behind this constant, and how this UVLAN ID is supposed to be being used to be able to identify that that's a bug. Or, if we're identifying end days, we can try to find all those places where things got flipped. So let's go ahead and do what we were doing before, bin export. we're going to export the old one first. Cool. Now we'll export the new one. Like so. And then we'll go over to the command line to actually do the bin diff, to make the diff file, vbox, and bin export, vbox 12, bin export. All right. And now I'm going to open it on the new one. Plugins, bin diff viewer, match file that, and I believe we're looking at the secondary. And those function addresses are different now. They should have been the whole time. And apparently I closed the bin diff window. Bin diff viewer window. Cool. So 18012. 12 BE10 B 12 B. All right. That's in the primary. And that's it in the secondary. B BE10. We have BD10. B. Okay, what's it? What's the address in the old one? Well, BB40. So in the primary, it should be 12 BB. I mean, this is also being matched by similarity and not technically address. BB. Yeah, we have BBF0, but not BB40. So let's sort this by the primary's address. Well, and we can see that a bunch of things did move around. And we have the BB40 function now. And we also have call reference matching. That's interesting. And then, well, BE10. Okay, so those functions do match. And I can click them just to bring me to the place in the file. And I can port symbols if I want to. In doing that, did it rename that function? No, it didn't rename that function. But I'm guessing if I make this thing, like this structure, for example, maybe it will. And I don't know if I probably need to regenerate the whole file after doing something like that. Yeah, so if I do plugins, so I added a symbol in the old version of it. Save and export file, save, replace. I made a change in the old version of it, and now I'm regenerating the bin diff files. Bin diff. And I reopen now that diff. plugins, BinDiff Viewer. I'm currently looking at the primary. Let's sort things by the address in the primary this time. We go about halfway down. 12B 12BB40. Right there. Now if I port symbols over now. Oh. Kinda would make sense for that not to work. If I do it from here, BinDiff viewer, open the BinDiff. I'm now in the secondary. Sort by the secondary's address, go about halfway down. In this version of the program, it's 12BE10, 12BE10. Well, it's not copying over my function name or my local variable name. I guess I don't know what port symbols does. And perhaps it's broken. Perhaps. Or perhaps I'm just using it wrong, which is somewhat more likely. Also supports putting symbols from one Netsch database for the other. It could just be for function names. Not entirely sure. But there are like this here is one. I guess this is the one I've named. If I port that symbol over. Ah, there we go. Okay, so that worked. So it looks like it is at the very least function names. If not also symbols. Just symbols. If not also local variables. It would be nice if it were able to copy over local variables, but I suppose we'll take just symbols if we can just get symbols. And funnily enough, no, it looks like maybe these two just had. We go here. Oh, well, let me navigate in this binary. But I can copy out the primary's address, go to that function. Oh, I want to close my export. Let me just copy that field. 18123E20. I won't. Huh? 18, yeah, I won't. But we know what it is. 123, was it 020? Oh, I didn't mean to. 123. E20. That's that address there. And then in the secondary, yeah, I think this one has the same symbol in both locations. Seems to. Alright. I was wondering if maybe there were symbols in the older version that didn't get stripped out of the newer version or vice versa. But these symbols seem to be just whatever the default demingler stuff is doing, which is fine. And well, last time we were on stream, I was showing you guys how you can build, or not last time, but 2 times ago when we were on stream, I was showing you guys how you can build the semantic types for variables. And in this instance, we can do exactly that and probably see the difference between these two. Plugins, calculate structured type, plugins. I did clean this up a little bit, by the way, before I put it in the stream channel in public chat, in public Slack. So it should work a little bit better than what we had on stream. Plugins, calculate structured type. If we look at this, mod u, struct field init, And okay, it's the exact same type there too. I need to make the .w operation transparent probably. But we, in theory, should be able to see the same variable being used unsigned and signed over two versions of a program. But anyways, we can move on from this. I do have other binaries for us to look at and put more time on the clock. Looks like there are a couple more people with us now than there were earlier. Thanks for coming. Thanks for joining. We're just bug hunting. So we started with this one, and I was hoping we could make some little automated script to find this in this program and in other programs, but I don't think we could do it without a deeper semantic understanding of the program and the variables and the constants being used. So maybe we can throw it at an LLM if we really wanted to. Like if we asked a really leading question to, that was not the address of the function we've been caring about this whole time. There we go. And it was it like BB? Oh, well, this is, I guess, exactly what bin export is for, but let's use this string instead as an anchor point to find that function. All right, cool. So you can use bin export to find the same function in two, and bin diff to find the same function in two programs. We could do the other one. I just want to see, I was suggesting we could throw it at an LLM. We have an LLM built in. Um, is there a bug on this line? Yeah, I've noticed Sidekick doing this a lot. It has my current location and the current file. I think this is an update on OpenAI's end. I've noticed that OpenAI in general, ChatGPT, whatever the latest one I've been using is, whatever the default, whatever it defaults to, is like prompting you to give it more information for things it already knows. I was asking it something that had to do with like scheduling, and it kept asking me what the time is. I'm like, what do you mean I need to tell you the time? You're a computer. It's one of the things you were built to do, to tell time. So anyways, specify the line or provide a code snippet. The current selected line in the current open function you have access to. Tool use skill issue. It's exactly a tool use skill issue. I need to retrieve the currently selected line to analyze it for bug. No code or instructions are currently selected. Oh, thank you, thank you, thank you. Let's just give it what it's asking for. Given this, I really don't think it's going to. Yeah, it depends on the intended logic to determine can you trace this variable through the program and find how it's being used? So behind the scenes, Sidekick should be able to generate BNQL queries for us, and you can see that it is. I could not locate the function or code context for the instruction at address. Wild. Please ensure. Okay, so Sidekick is just joking on this one, which is unfortunate. I do believe that's because of an OpenAI update that's gone bad, and we might need to fine tune our prompt or roll back to an older model or something. We'll see. I found that a lot of like we go into a lot of TikTok cycles with the LLMs, not Sidekick, but just in general. I've noticed one update is worse and the next one is better, and then back and forth like that. Yeah, I've heard a lot of people are at this point able to automate junior engineers in general if they're able to give it enough context. And yeah, tools and stuff. Okay, so let's go ahead and model another CVE. This one will be easier to model, I promise you. They'll have a lot fewer false positives. I've got it's CVE 2021 31956. I do need to call out Secure List for bringing my attention to this particular CVE way back when. We also have a video about this already on our YouTube channel. But I don't believe I've modeled this for you guys before, but we've never gone in and I could have sworn I had a bookmark. Oh, I don't have a bookmark. Oh, I do, actually. It's just on a different version of this. That's fine. We can rededuce it from first principles. In this case, and in general, this stream, we've just been looking at blog posts and or blog posts in similar types of CVE reports and trying to remodel them in Bidja. And you'll have mixed success, but this is about how I'd approach the process in general. Try to find some anchor points. In this case, we have symbols in this binary, so we can see the places that this is being called, and there's one that's inside of an if statement, which is similar to how it's being used in the blog post. So now we need to find, just after that comparison, another conditional check with a comparison with a subtraction in it. So that's down the true branch. We can see an addition. And we can also see down the false branch. Interesting. arg5 minus r15, arg5, out buff length. Makes sense as a name. Let's see. These look to be doing very similar looking things. RSI plus 3 is greater than the length. If that's true, panic, I imagine. Yeah, overflow. So it's correctly checking it in this branch, and it's not correctly checking it in this branch, and it looks like the compiler flipped the true and false branches here and here, which is fine. So we've got that. Let's just model this. So we can go to the template I showed you guys up at the top and do Open Tonto and do this whole thing again. We can create the new slice type. We're going to make the instruction graph and hunt that down over here. This is the instruction we care about. It's going to be comparisons this time, greater than comparisons, where the right-hand side is a subtraction, and we can stop there. So let's find all of those in this program in ntfs.sys. And you'll notice a number, not an outrageous number this time. We could realistically go through all of these and see if both variables are properly bounded. I am looking for the one at 2C53 right here. So it was found and our script is done. So we found, how many did we find here? We found 16. 1 out of 16 is 6%. So we have 94% of the way to go on filtering out false positives, or one of these other locations is actually vulnerable. So let's go ahead and start filtering these out. What I want to check is we can, well, let's start by just grabbing this current IL instruction. And we can grab the variables out of this. We actually don't care about the instruction. We actually only care about the condition field. So we can say inst is that, inst dot right is going to contain the variables we care about. So let's make this a snippet because this is going to be a little complicated. Let's make a new snippet. This is going to be NTFS right there. Let's copy in our template. Paste that in. That did not copy what I thought it copied. Oops. This here. There we go. I can save that. I can now also open this in a real code editor if I want to. That way we can have, don't need this anymore or that. Let's open this up on the side. Open up my Binary Ninja workspace. Remove the virtual box. Remove. Cool. And now we can go to my snippets. We can see the NTFS one. And there we go. So you can open this in your code editor. There is a button for it in the UI there. I could have pressed instead. But I like to keep all my snippets just as one of my folders in my editor as well. So I will need this open. Well, I don't need this open. Just to click run. You can actually, if you do Command P or Control P, I call that NTFS. You can see it's registered as an action. So I can just run any snippet from right here. You can do that. Output should go in the log, which has been just screaming errors at us for a while. And you can see a whole bunch of our matches come through as they come through. Sweet. So we want to filter these. We were looking at the right-hand side of this, and what I was going to do is I was going to bind those two variables that are in the subtraction to something in my script. So we can say here we have the subtraction. Open up Ponto again. Click back into the instruction slice. Seem to have navigated us on the left. And we have a dot left and a dot right, which are these things. So we can say right as var1, left as var2. There we go. That's okay. If we really wanted to, we can do a from Binary Ninja import star at the top. Right is not accessed. Local variable var1 is assigned but never used. All right. So we have var1 and we have var2 now. Let's do that on the console. Left, I think it is. Perfect. Oh, and that's the high level IL variable. So we actually want the dot var off of that. There we go. So you have over here the variable instruction object, but then the dot var gives you the variable object. The variable instruction object will have information about that specific instance of the variable on that line at that point of the program. Like you can grab the dot possible values off of with the variable instruction object. It has a dot possible values on it. If there's a value for that variable at that point in the program that's different from a different point of the program, that's why you want the variable instruction objects. But off for some other APIs we're going to be using, we want the actual variable object itself. I didn't personally finish Flareon, but I do believe my coworker finished Flareon. I will pass on the congrats. I actually haven't looked at Flareon. I was thinking about whether or not we could take a look at them on stream, but um, I believe it's still running, and that would be fair. I've been a little bit out of the loop. I was at Hexacon last week. Only got back from Paris on early Wednesday morning. I think it's still currently, my sleep schedule says it's really early in the morning. I'm a bit sleepy. But anyways, we've got our right and left sides of the sun sign comparison here. Those high level IL variables versus the actual variable objects themselves. I want to see whether these variables are used in another instruction together. That's going to be my first step. Do we see these variables interact anywhere else in this function? If so, let's mark it safe. That's not a good thing to do, but it's going to be a first crack, and then we can refine. So, right, that means we can't just say that. We need to pull out the high level IL var. So right equals the high level IL var, and then it's going to be var as var1, and it's going to be the same for the left-hand side. Cool. So now we should get inst var1, var2. Let's see if this works. Python match syntax is really weird, and I get it wrong sometimes. So it is good to practice and double check yourself. Multiple assignments to name var in pattern. Okay. So can I bind var if I say var equals variable maybe? Like is that how we bind it correctly? Please, somebody correct me in chat if you know the syntax for this and I'm messing it up. That did it? I'm actually a little bit surprised. Let's stop printing out the entire instruction and just get the, well, okay, so first of all, this looks like possibly a lot more results than we were getting before. Because we're getting a whole bunch of unsigned greater thans, but they're not unsigned greater than with a right hand side of a subtraction. They did it wrong. So we have the unsigned, that's a subtraction, and then the right and left. Wait, unsigned greater than, the right hand side, dot right. Yeah, I do believe we're just missing a level of indirection here. So where this right needs to be the subtraction, and then the right hand side of that subtraction needs to be a high level IL variable where we're binding that variable to var1, and the left hand side is also a high level IL variable object where we're binding that variable to a var2. Now this will miss when we're subtracting by a constant, both sides have to be variables. And this is also what I mean by match syntax being weird. I would not have expected that. No, I guess that actually does make sense that it worked. We were just finding all comparisons with a left hand side and a right hand side that were variables. Which is fine. I'm glad we can do it. But let's do something more useful. Did I run that? Clear log. Run it again. Oh, it's already running. And already, it looks like we're getting some good results. Exciting. So we've got, again, I believe this is the one we actually care about. Let's put a bookmark on it. I'm going to do command, I believe it's option 1. I have a Windows keyboard, so it's Windows Alt 1. But I believe it's command Alt 1. Yeah, it is. How do you unset a bookmark? Remove bookmark? That removes both bookmarks. Anyways, control option 1 or, sorry, command option 1 or control alt 1 should set a bookmark. So we've got that one. We've got this one and we've got this one over here. Now this one, we do check that. All right, if all this is less than that, and we're checking that up there, but are we ever checking? We are. Yeah, see it right there. So we are properly doing this check on this version of it, and then we are hopefully doing the same up here. Perfect. Okay. So we can model this now, and we can filter out both of those false positives. Already, we've eliminated a ton of uh, results because we were previously finding all unsigned comparisons with a subtraction on one of the sides. Now, we refined that down to a subtraction with 2 variables on one of the sides. So we could go back and now also look for versions with constants, but let's stick with this for now. And maybe we can run this on another file afterwards and see if we come up with some other results. I'm a little bit tentative to do that just because I don't want to accidentally find O-days on stream, but I think I have some old enough binaries where we don't need to worry about that. All right, so let's collect, I guess, just all places the first variable is being used and then all places the second variable is being used and see if those places ever happen to be the same place. We could be really explicit and traverse everything in this function to find the correct type of comparisons. But let's not. Let's be lazy. And in being lazy, maybe it's harder. Um, because, hold on. Let's do it both ways. I've got myself, let's give this a better name too. This is not just traverse. This is match sub bar. All right. And then here we can say we'll just call this traverser for now. Oh, I usually call these traversers, not just traverse. I believe I said it wrong originally. Traverse, traverser, not traverse. I think that's just slightly less confusing. All right, so we have our traverser now. This will take an instruction, and this time what we're matching. Oh, this is also going to take the 2 vars, var1 and var2, and now we're saying I want an unsigned less than comparison. Get Conto up. I am not performatively using Tonto to write these, by the way. I am legitimately using it to help. Where's that comparison? This is a unsigned less than. That where the left hand side, so less than, needs to be the left hand side of the subtraction. So that's going to be var 1, where the right is, and remember this, we've got this nonsense going on here. We don't care about the subtraction anymore. We just want to know that and yeah, if it's annoying anyone else that I put the right on the left and the left on the right, I did think of it earlier. And I just ran with it. So let's go ahead, do that. Then it looks like cool. Let's fix that over here too. The left on the left, the right on the right. All right. All right. So then we've got unsigned less than, where the left var is a. Can we do that? I don't think we can do that. Can we do that? No, I don't think we can do that. I do think we can do. Ooh, this is tricky. Let's try that. Let's see what it gives us. We've also now flipped our bars. Make that bar 1, that bar 2, that bar 1, that bar 2. And we could give them even better names like LHS and RHS if we wanted to. I guess it's easy enough. RHS or LHS. Cool. And we're not just returning this. Now let's just return true. Okay. So now if any instruction, let's call this safe size check. And we can say match safe size check. I still don't know 100% if this is going to work, but we'll give it a go. And we'll say if, and I believe that there's a function level traverser as well. So current IL function dot traverse. I've not actually ever used this one, but it iterates through all the instructions in the function and returns the callback for each instruction and sub-instruction by non-constant memcopy, blah, 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 current function, dot traverse, or result in that. I think it works just the same way. So if you can't be more narrow in applying this to individual instructions, and if you're not just doing it for every instruction in the binary, you can go ahead and do it for just the all the instructions in a function pretty easily as well. So in this case, though, we have the current IL instruction, and you need to get the IL, no, you need to get the function off of that. So if we do inst dot function dot traverse, oh, and this is going to be again a generator. So we, I believe, need to say any. And do we need to wrap any in a list? I'm not sure if we do or not. If any can take a generator, it should be able to take a generator. So if any instruction in that function has this safe size check, and we need to give it the variables var. It is the AI autocomplete is correct, but we can be lazy as well. let's try this and see if it works. He run the last thing we ran, and nothing matches. Oh, we get one match. We get all three matches. Okay, so that equal equals thing isn't quite, or sorry, that single equals thing is not working quite how I wanted it to. Um, and can we do that? I don't even know. I don't know if this is valid Python. But again, match syntax is weird. Yeah, it's warning me it's not syntax error. So this is my next guess. And again, if anyone would like to correct me in chat, you're welcome to. Var variable is, ooh, it really doesn't like that. Am I missing expected a, no. Let's look at the docs. I do believe you need to have the if statement, um, outside. Yeah, right here. There can be zero more elif parts. Case. Match statement, cases. I didn't realize you can do ors like that. That's neat. You've got these, x, y, match point, x equals 0. So you can say that for constants. And you can bind variables that way. But how do you... You can use positional parameters with some built-in classes that provide in ordering for their attributes. You'll also define the specific position by setting match args attribute in your classes. Interesting. If it's set to X, Y, the following patterns are, wait, yeah, the following patterns are all equivalent. Yeah, because we're either matching so it's doing it positionally, or explicitly saying the variable there. I do believe it is, again, binding Y to the name var in this instance. Put the left, wait, look at them as an extended form of what you would put on the left of an assignment to understand which variables would be set to what. Only the standalone names, like var above, are assigned to by a match statement. Dotted names like foo.bar, attribute names like the x equal and y equal above, next to them like point, are never assigned to. Cool, that's fine. But how do I then say, how do I match an object? Ah, x, y, if x equals y. So let's pull out var as var1, var as var2, and it looks like I can probably do it this way if I wanted to. And then throw on the end of this if var1, I was going to say is, but equals equals is fine. Equals equals is probably more correct. They're not going to be the same Python object, but they're going to have the same handle and pointer to the same variable in the core. So you probably need the equals equals instead of the other version. Let's run that again. Let's also be kind to ourselves. Uh, Starting scan, and then done. Oh look, it found more things than before. Or I ran it twice. I ran it twice. Alright. So we're still not quite there. Is it? Alright, starting scan. Run through everything, print the false positives. And then tell me you're done. Tell me you're done. Done. Cool. Alright. So if any, ooh, well, I do believe it's still. We could go ahead and just throw some extra prints in here. Those are going to both return true, though. If it's not, I'd be concerned. We could also actually just do that. So if R1 equals, let's print that. But let's also print results. Let's get a list of this and print it. Thank you. All right, results. Do that. And let's run this. Okay. Cool. So it is working, but it isn't. Um, Starting scan. True, true, false, false, true, false. That's for the first one. And then for the second one, we get true, true, false, false again. What is the order in which things are printing? It should print whether or not those two variables are equal. And true, true, false, false, true, false. And it prints the results of those. Okay, so we don't need to print this. This is a little redundant. Let's clear the log and run that again. Why am I getting an empty list at some point? Why is it printing results twice for that one? Well, we're matching the instruction. It prints results before it calls traverse. Hmm. 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 Anyways, it is printing them above though. So, and this is the one that it should be printing. Oh, 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 oh. wants to play again. If you can hear her screaming in the background. Um, I do appreciate the reacts for the cat. Um, this is confusing, certainly. Um, I think it's where's that called a traverse? We've got those and those. We've got results. We're getting a list of results. We're giving it the left hand side and right hand side. We're matching. Oh, right. No, this should be fine. We don't have to call traverse from within traverse. We could just return that and then like this. Destructure the return values there. And then what is the AI suggesting? I don't like that. Reverse the entire function again. Yeah, let's do this. Results list, traverse through everything. Um, let's do like an actually decent log print here. We can print the address, we can print the instruction, we can print we don't really need the left hand side and right hand side, but we can print the result. And then this is actually going to be if not any results, right? We got the thing we care about. Give that a go. Sweet. Var LHS is not defined, which is correct. We just call it LHS and RHS. Log, and then run NTFS again. Binge is getting unhappy. Okay, so it is correctly identifying the one we care about. Um, and it's getting, I see what's happening now. It's matching, again, all the unsigned less than comparisons in the function. So there's going to be several unsigned comparisons in each function that returns false because there's a whole bunch that there's just a whole bunch of other unsigned less than comparisons in the program. If any of them have those two variables we care about though, then we want to ignore it. What's confusing me at the moment is previously I thought we only had 3 results and now we're seeing 4. Let's take a look at them. This is not the one we care about because as we looked at, that one is safe. This is the one we care about. There are no instructions. There are, first of all, no unsigned less than comparisons. There's also just no other comparisons that blah, blah, blah. Then there's this one. which gets checked up there. And there's this one as well, which gets checked right there. So, not sure when we started going from 3 to 4, but it looks like this works. So if I simply move this up one, and give it a nice little thing there, found a comparison, found a subtraction in a comparison that isn't checked. And instead of printing, we could add a tag. It would literally just be inst.add tag. We could call it, well, let's just do it, bug, and then you give it oh no, sorry, it would be the function still. So instruction dot function, I believe dot source function, because you need to add it on the base tag, base object, I should say. We should really just have an inst add tag. That would be nice. Current IL instruction dot, function dot, so do we already have the source function? We don't. So function dot source function dot add tag. We need param1, the data of the tag, the tag type, the description, and then the address. So we can do the tag type is bugs, the description is this, and the address is insta address. Sweet. So, starting the scan, it found the subtraction we care about that leads to the bug, and it added that bug tag for us. Sweet. So now you guys could just add a on analysis completion callback, call this code, and you'll find a bunch of things. Let's see if this works on any different binaries. Well, first of all, let's check the patched version. That's a good sanity check. It would also now at this point, I wouldn't want to break here. But it would be nice to explicitly say whether or not you didn't find anything. Gotta wait this out. There we go, done. And then didn't print anything, didn't add any tags. So the patched version is patched. Yay! Let's see. All right. So there we go, guys. That's our script. That's our reversing. That's our CVE hunting. We looked at this vulnerable version of NTFS, which we're actually able to model. This is more of a bug class, though, that we're modeling here. Just a subtraction and an unsigned comparison where the two variables are not bounded. We also took a look at, of course, this VirtualBox thing and tried to, was it that? No, this. Tried to find this, but I can't think of a pattern to generically match this because, again, not a bug class. We can find all unsigned comparisons to a constant, but we'd need an LLM to tell us maybe some of the semantics, or actually just sitting down and knowing the code, being able to map this to source. If we were able to port over the pound defines to identify that everything are maxes or constants or something, that would be helpful. But again, this is a harder one to find generically. All right. So I do have one more. We could do one more. How long? Oh yeah, let's apply this to some other binaries. That's what I want to do. I am tempted to do one other one. Yeah, why not? And I also said, didn't I say I did this two ways? Yeah, we explicitly matched for the unsigned comparisons. We could have also just said, are the two variables used together? Yeah, I like the more specific answer. We'd have to refactor this a bit to get the less specific answer. And is this safe? I think that this is safe because if there's a type of comparison that we are missing, give me a second. Dad is calling my phone off the hook at the moment. Need to turn off Bluetooth here. Keeps stealing my attention. There we go. I can read the message he's giving me. It's nothing important. Um, but it would be nice for my headphones not to be stolen. So this, I believe this is safe because I believe this is safe because we're being very narrow about what we're matching here. We're saying in this function, there's specifically this type of instruction with these two specific types of variables. And we're not just saying if they're being used together. So it's not like if they're used together in add or a different subtraction or something like that. So I do think that this is more safe than the other version. And honestly, pretty easy. We have two traversers here. We're using them in parallel. We no longer need that temporary value. So we can clean this code up a little bit. Let's just make sure. And I'm going to leave the print. Maybe even turn those into log alerts or log warnings if you want. But just as a sanity check, let's make sure it's still working on the vulnerable version of NTFS. I didn't break anything. Oops, I opened the console, not the... In there, it's able to find it over here. This is not our bug, the maximum recursion depth there. Cool, that's still working. So if we go ahead and try on some of our extra binaries for today. First of all, I am really tempted to do it just on the DLL we were looking at before. Let's go. I'm gonna hold off on that one. Let's look at the other ones first. We can come back. This version of VirtualBox is newer than I'm comfortable with. So let's look at these old versions of BusyBox and Nginx. Okay, cool. So let's just go ahead, run that here. Open up the log, it's starting to scan. Apparently I didn't wait for analysis to complete, and it says done. So I found nothing in BusyBox, that old version of BusyBox. What about Nginx? Ooh, it is finding some in Nginx. Again, ancient version of Nginx. So hopefully I'm not handing out free candy right now. Let's see. If I is greater than this minus this, and we're grabbing that out of arc5. So this could, well, let's actually, are those, oh geez. Yeah, this is a decently sized function. Where else are these offsets being read from? Is my next question. We would want to make sure that arg5.7, and in fact, arg5.7 is being, and arg5.1e are being used explicitly elsewhere and not just the copies of them. So we might have a safety check earlier on that is correct. So not guaranteed here. That's the one we were just looking at. Oh. These all seem to follow a similar pattern. Or the first two did. And this is exactly why I made Tonto. Where are these variables coming from? Well, let's take a look. Open up Tonto. We're going to make a variable slice. Variable slice. Okay. Let's go back to that tag. This third location. Right here. And I care about where that variable is coming from. We can see the use of it somewhere. And it's assigned in a lot of locations. So this is our use of it here. And the previous assignment is a copy from var8. So we add var8 to the variable slice. It itself is coming from i7. Don't lose me. Aw, the Tonto view got desynced, I think, when I hit back. Yeah. So i7 is coming from i8, and several other assignments to i7, but I guess we only care about, oh, this could be a distinct variable. We might want to split the definition of this. Well, yeah, okay, it says we shouldn't. Okay, doesn't look like it changed what I would have wanted it to change. So I'm going to hit undo. I was probably wrong. Binary Ninja is usually more correct than I am. Yeah. So if it's a bug, it's certainly not trivial. Um, uh, just trying to find it again. Keep losing it. There we go. Are these on the same? Yeah. All right. Yeah. Big functions. I do need to add the option back to hide all these grayed out nodes. These are dominating conditions that lead to the definitions and uses of your variables, which is helpful for context, but not necessarily helpful when your graph gets too big. Um, like too big, and there are a bunch of dominating conditions. But anyways, I think that's where I'll end this analysis here. Um, it is interesting that I found things to me. I do think that this one is a false positive. I think we need to see where those are being, where else those offsets are being accessed. And then this one's just a big function. You'd have to sit down and think through it. I do have a different version of BusyBox, though. I have a slightly newer version. If we run this script on here, found nothing. Oh, it did found something. It found. It's also not running on the right binary. Oh, apparently I am running that now on Virtual Box, which I wasn't going to before, but whatever. It looks like if the left hand side is a less than, is this a guaranteed over underflow? Um, well, I'll let you guys have fun with that one. Um, this does seem like a bug, unless I am. No, this one's probably a bug, unless it's doing something really funky with the math here, being like just flipping the sign or something. But that looks like a bug. And okay, this one's probably, yeah. If RDI, wait again, unsigned. Oh, false. I see. Okay. No, we're safe. Hey, puppy. Um, this is not a karaoke stream, unfortunately. So if that is bigger than we break, yeah, cool. So this one's safe. So we do need to implement the opposite. So let's do that. Since we found a counterexample, since we found a false positive, let's filter it out. And now this one is going to be just a greater than, an unsigned greater than. Previously we had unsigned less than. So if we have an unsigned greater than the, oh, we're also not checking the path sensitivity of this. We are just saying if it is ever, if those two things are ever compared, if this block is over here, we're also introducing bad behavior, or bad scripts, I should say. Scripts that are missing things, missing missing false positive, missing true positives, which means they're unsound. I believe is correct. They're also, they wouldn't be correct. So in this case, we want to flip the left hand side and the right hand side, basically. So does that filter out 3, 6, 2, 1? How many did we find? 1, 2, 3, 4, 5, 6. We found 6 previously. Um, Copy those, clear the log again, and then rerun our script. one. Round two. Okay, so here we go. Now there's an equals. And, ooh, okay, we're looking at this one. And this one could be a bug, although something certainly is going on here. So this would take more analysis. But it filtered out a bunch of the other ones we saw. So I guess I was just thinking through I copied all the previous addresses. Um, yeah, this one I was looking at before. If RX5 is bigger, then we don't do this. So yeah, that seems safe too. But again, it would be important to actually walk up your nodes and ensure that comparison is in the right location, dominating you. You have to go through it before you get to it. Sorry, you have to go through that comparison before you get to yourself. And of course, like all good things, Tonto can visualize that. Um, Go over to Tonto. We can do our dominators, and then there we go. Then we can see we should have to go through that block. We have to go through that block, and then yeah, we have to go through that block too. So you can walk up your dominators and check those instructions instead of checking all the instructions in your function instead. So yeah, if we wanted to make this script even better, um, do walk up dominators instead of hold on. Which wouldn't be that hard. It would literally just be a for basic block in dot. I think it's going to be il basic block dot dominators um for in two in pb, then this stuff here, but you'd still need the set because you'd want to make sure you're getting all the things. So it would like in progress something like this, but we need to add a list and keep track of all our results. There you go. It is interesting how I don't think I've noticed this implemented with or implement with Codex. I see. It's trying to implement the to do comment. Funny. I don't think I've noticed that before. All right. So I think that's where I'm going to wrap this up. We've got a couple more things to talk about. Don't leave just yet. We've got the question of the week. So I did tip of the week at the beginning, and now question of the week at the end. So thanks for those of you who have stuck around. The question of the week we got this week, and I get this a lot, is just how do I contribute to Binary Ninja? It's a cool project. I want to do things on it. I'd love to get my name in the changelog, all that sort of stuff. You can go to the API repo and just check out our issues. We have tons and tons of low effort issues, effort low, or even trivial, that, yeah, here we go, which hopefully don't have the core tag on them. If they have anything tagged as core, then it requires core changes, so you can't work on those. But there should be others in here that you can. All these are tacked on with core. I'd recommend maybe starting with here. We're always looking for more plugins, of course. A lot of the things we develop officially, we develop as open source plugins. So we have our Objective-C representation here, and we have our architectures, and we have our views and stuff and such stuff like that. We can always afford more views if there's a file type we don't support, or even if there's a file type we do support. I know that if we look again at the labels, go to PE, there's a ton of open and maybe even effort low or trivial. PE, oh, okay, there are no easy PE bugs. But if you want to go slay some dragons, I suppose, you can. There's totally effort low. Oh, was it ending all of those? It had to be low and trivial. Um, so anyways, yeah, there are tons of low effort and trivial effort bugs you can go fix if you want to go fix some bugs. Make get some good wins. You can even sort by the impact if you want to do things that'll have larger impact on the community while still being easy to implement. And what else did I have here? New file formats, new architectures, new platforms, new language representations, type-libs if you want to. One that was suggested that I think is interesting is go through the API. We have 3 APIs now. We've got the Rust API, we've got the C++ API, and we have the Python API. If there's anything that's wrapped in one API but not in one of the others, we would usually accept more bindings for APIs. There are some things that are left unbound just because they are kind of useless. So give a little bit of thought towards. Oh, I should. So give a little bit of thought towards what you might be trying to bind. But there's lots of gaps in the API. There's also documentation, bugs to be fixed. There's APIs that just aren't documented if you want to go write some documentation. Lots and lots of ways to contribute to Binary Ninja, from very, very intense building out language representations or architectures or stuff like that, all the way to writing documentation. So whatever you want to try your hand at, you absolutely should. And you can go through our 1.8K issues to find something in there. But beyond that, we've got hopefully a stream on Halloween, the 31st. TBD what we're going to be doing. We've got the next release of Binary Ninja slated for November 12th. And then I think it's later that same week. Or maybe the next week, on November 17th. Is that the same week? That can't be the same week. Apparently, I don't have everything showing in my. Oh, here we go. I'm in the wrong month. There we go. Yeah, the same week. We've got the release the 12th. And then on the 14th, I believe I misspoke, we've got Tim Blazeko coming on. He's one of our Reverse trainers. We're going to be doing an interview with him, asking him some tricky questions about all sorts of stuff: reverse engineering, exploitation, the obfuscation. Hopefully have a good discussion there. And there's another interview being planned as well with a different one of our trainers. I don't have dates for that yet, though. And we've got Reverse coming up. The CFP closes in about a month now, I think. So go ahead and submit to Reverse. We'd love to see you guys there. But that's all I have for tonight. Thank you guys for sticking around. It was a lot of fun. I enjoyed myself. We did quite a lot of using Binja, using BinDiff, using the API, hopefully showing you guys using Tonto, showing you guys hopefully a couple new tricks you haven't seen before. I hope you enjoy it. But with that, I believe we roll to the outro. Thank you guys. I'll see you next time.